Hello everyone. I hope you can see my screen and hear my voice. If not, please let us know in the chat. I would like to welcome you to our very first webinar about SCIA AutoConverter. This is Adam Vyskočil and Vítek Vondráček. We are both part of the development team. We are excited and proud to introduce you SCIA AutoConverter, a brand new product from SCIA company. And I'm going to give you first a brief intro, and Vítek will do a hands-on demo to show you how to use SCIA AutoConverter. Before we start, I would like to inform you that the webinar is being recorded and will be uploaded to SCIA YouTube channel. Please ask your question. Feel free to ask your question anytime. We will try to answer it during the presentation, during the webinar, or at the end of the presentation. Or if you have any feedback, please write it down, and we will be very happy. So let's start. First, let me briefly explain our workflow. I would say that this is quite common BIM solution or workflow situation, that we have structure model. Of course, we have architecture model, we have MEP model all together. But as you can see, structure analysis model is quite outside or on the side. So what we are focusing with our solution is to improve this link or this coordination to improve this integration, I would say, between structural model and analysis model. How it's work? Let's start with the BIM Plus. That's our common data environment. It's a cloud-based solution where you can upload your models. On the left side, you can see this is a bunch of model applications where you can upload your model from. Only what's needed is to have possibility to export your file or model to IFC, or you can use directly API. When this is done, you can see your model in the BIM Plus. You can do a lot of other things here with that. You can collaborate. You can share your model with your team and colleagues. And finally, here we have our web-based web application called SCIA AutoConverter, where you can create automatically analysis model from the structural model. When this is done, you can export your analysis model to your application, software analysis application. In our case, it is SCIA Engineer. We have direct connection to BIM Plus, or you can do it via SAF. SAF. Let me briefly explain what is SAF. SAF is a structural analysis format. It's developed or introduced by currently it's 9 different companies which are in software analysis development. We are collaborating. SCIA is leading that, but as I said, it's a collaborative platform or project. And it's in fact it's Excel file. It's a description of analysis model. It's easily can be read by the user. And yeah, please find more. Maybe in the end of this presentation you can find more info in the links. So that's it. But that's not the end, because you can also do some changes. For instance, in your analysis model, thanks to your design, you can make the size of the dimensions will be bigger, or you change the material, or so on. You can upload your model as a revision. You can do the comparison, and that's it. The same is valid for the structural model. When architects do some changes, you can see it and you can work together. So we know where is the connection, because we are creating the model from the structure model, so we know which object is related to our analysis object, so we can track the changes and you can continue work. You don't have to redo all the time your model. And let's check how does it work. So first you have to upload your model to the BIM Plus, to our cloud solution. Here you can see your model. first you have to clean your model. We have quite powerful tools for cleaning, so you need to get rid of all the elements which are not related to structural analysis. Like in this case, you can see roads, for instance, or trees and so on. When you are done with that, we are running recognizer. That's algorithm which in fact recognize each structural object from your model and do the, I would say, analysis model representation or object representation. So it's recognized as a single axis for if it's a 1D member, or if as a plane if it is 2D member. All the attributes which are related to structural analysis are kept. That means that we are able to recognize thickness of the wall or slab, material, or also dimensions of the cross sections. You can also define how each object should be recognized, if it should be 1D or 2D. For instance, if your column is wider, then you maybe want to have it recognized as a wall. So you can, all these settings can be set in recognizer. We are also providing possibility to filter all small elements. So after recognizer, we know all the dimensions of the object. So you can say, for instance, all slabs which are smaller than a specific area will be deleted, so you don't have to spend time with some small nonsense structural analysis, structural objects. Also, we have quite powerful mapping for materials and cross sections. But I think Vitek is going to show you more deeply in the demo. Then when the recognizer is done, of course, the objects are not connected. So this is going to happen in alignment. You can define the system line position. That's quite useful for steel structures. You can set if it's the top of steel, bottom of steel, and so on. We have also possibility to define maximum movement of each node or member. So sometimes if the gap is bigger, or the one element it's moved how you don't want to, then you can set it in your settings. Also, you can set eccentricities if you want to take it into account in your structural analysis software. Then there's quite powerful tool. It's freeze elements. That means that during the alignment, some objects are moved or trimmed or extend, of course, to be connected. And by the freeze elements, you can set objects which are going to stay on the same position. They are in fact freeze during that alignment. Then also there is options for partial alignment. That's valid when, for instance, you want to align only part of the structure first and then the rest of the structure. So all what is currently selected in the application, take it into account. The last step is to publish your analysis model. As I said, you can do it via subformat or directly read by SCIA engineer. And yeah, the final step is to take your model to structural analysis software. In our case, it's SCIA engineer. You can here do your job. That means structural analysis design. So you can add your loads, boundary conditions, and do the design and upload the model back as a new revision. That's not the end. We can continue with the workflow. So imagine that the geometric model has changed. Elements can be moved, or the size of the element can be changed. Maybe material or some elements could be also deleted. So if you upload your model as a new revision, then you can use the revision compare and see easily and clearly the changes. So for instance, here you can see that the walls are deleted and other changes are made. In the revision compare, you can see in the 3D scene the results. It's up to you to accept the changes. So you select it. You select the changes which you want to take into account to your structural analysis, and you can continue and update your analysis model without necessity to redo everything. So it's really safe. It's really a lot of time in your workflow. And the last step or another workflow is that something can change in your analysis models based on your design. So again, the same changes, you can delete some columns, you can add some objects, or change the dimensions of the cross section, for instance. You can do the same, so it's very easily, you can upload your model as a new revision, use the revision compare, pick up the changes you want to take or carry to the next to update your structural model. That, for instance, from that table overview, you clearly see what was changed, also the value of the attributes, and you can, and we are then automatically creating the tasks which are clearly visible in the CAD software, the source CAD software. So that's what briefly I try to explain what we are trying to achieve, and I hope that Vitek will show everything in the next demo. So now I hand over to Vitek.
Okay, hello everybody. Let me just quickly switch to my screen and I will start. Okay, so thank you, Adam, for introduction and nice overview of what AutoConverter should do. And let me start with the part that Adam mentioned, and that is BIM Plus portal. We are using BIM Plus portal as a cloud solution and the storage for your models. And it looks like this. It's a web portal for the collaboration and exchanging the models with your colleagues or with your partners. And one of the feature, or let's say product inside the BIM Plus, is our SCIA AutoConverter. You can find it there on the left, and if you click on it, you will be redirected directly to the SCIA AutoConverter itself. But before I start doing something in there, let me just briefly talk about the BIM Plus itself. I would definitely recommend to click on this eye icon next to the SCIA AutoConverter, and there is a link to 3 videos to our YouTube channel, which can give you again some brief information about the AutoConverter, what is it for, how does it work. Also, the second video is very important. This is the step-to-step guide, how to start with it, how to start your trial, how to create a model, how to create a team, and etc. And there's a link for the third video, which is explaining in a nutshell the work in the AutoConverter itself. Our YouTube channel don't end with those 3 videos. If you will go to the YouTube and list full channel, you will see also other videos there which are describing whole workflow. So just go to our YouTube channel there, and there you will find the SCIA AutoConverter product, and there's a list of all other videos that you can play and start with. So really very useful thing to start here. I mentioned something about creating the team, model, and project. This is actually how the structure of the BIM Plus goes. You need to have your team first, where you have an owner rights to upload the models. Now, currently, I'm in my team, and you can recognize on which team you are by looking here at the top. This first part is a team. It's called by my name and some other things, and this is the model or the project I'm currently looking at. So I will just briefly show you the management of the models. Now on the left, I can see I'm still under my team, and because I'm under my team as a admin or as an owner, I can add the project. So just try to test. I will create the testing project. And there I can see there are all sort of other projects. And to add the model, I will click on this cube icon, and I can see this project has still no model in it, and I can change it by clicking on this plus sign, and then I can pick any IFC file from my hard drive, and it will be uploaded there. This is the direct link, how you can start your work by uploading the model directly in the BIM Plus. Or if the source application, the CAD application you are working with, it can be Revit, it can be Allplan, they have a direct link, direct API to the BIM Plus, so you can upload the model directly from that application. But if that application you are using is not using direct API, then you can always go here to the web page and upload it manually. So this was just to demonstrate how to do this simple first step. So now I will carry on to the SCIA AutoConverter itself and start explaining the whole workflow step by step. So now I switch to the SCIA AutoConverter, and yeah, first of all, I need to switch the language. It's now switched to the Czech, so I can switch to English for the purposes of the webinar. So you can see it was translated to many other languages. So I will switch to English. Okay, and now I can see I am looking into the team by my name. It's a team that I'm owner of, and I'm looking to the project called webinar, which I prepared for today's presentation. And here there are the models which are inside that webinar project. And I've decided I will demonstrate most of the workflow on the first glance, very simple steel structure, but it's not so simple. And I want to show you some tips and tricks maybe, and some nice features we have in the AutoConverter. So I will turn on the model by clicking on this eye icon. And now what you can see, this is the model which can be uploaded from the CAD application. It's a structural model, something that I don't know, the steel manufacturer, draftsman, or modeler would work on. Yeah? Maybe in Tekla, maybe in advanced steel. I don't know from where, but this would be his outcome, his work. But for the structural analysis, and this is one of the first steps you will always do with your model, for structural analysis, you might get rid of some objects that you don't want to be carried on to the analysis itself. In the picture that Adam was showing was some trees, rows, and etc. That's that's clear. But also in such a simple steel structure like is here, there are a lot of objects you probably don't want to work with in a structural analysis. For example, if I will zoom a little bit, you can see there are some smaller rods here. There are some huge connection plates, and etc. For the structural analysis, it's probably not. It's not very suitable to work with them. It would just pollute my model, and I just really would like to have a nice structural analysis representation, which means beams as a 1D and slabs maybe as a 2D, and that's it. So I'm going to do some cleaning, and for that I'm going to switch to the second tab here, which is called Generate Analysis Model from Structure Model, and this is the main part of the AutoConverter itself. It is the navigated workflow from the point 1 to the point 6, when the point 1 is selecting the structural model and the point 6 is aligned model, which can be used for the structural analysis. I've already selected the model, and I will carry on to the clean step now. I can clean the model and get rid of some of the objects basically by 3 ways. One way is to use the IFC groups on the left, which are based on the definition of the structural model, and I can click on it and the objects get highlighted in the 3D scene. I can use also the isolate function, so it's much more clear. So under the group columns are these objects, and probably I'm okay with that they will be carried on, so I will keep them. If I wouldn't like to have them in the model, I will just unselect them by this checkbox and they are gone. But it would be probably smarter to have some columns there than not having any of them. So this is the first instance of the cleaning. Just go through the IFC groups and decide if you want them there or not. For example, we are a little bit smarter than that. We know that the columns, beams, and members are probably objects that we want to keep, but plates are not so often, so by default they are turned off. But if I would like to, I can keep them on, but yeah, in this model, I don't want them there, so I will keep them unchecked. So it means they will not be carried on to the next steps. So this is the first instance. Another instance is so-called filtering, and there are two types of the filtering. One is based on the attribute and one is based on the selection. The selection is very simple. Just select something in the scene, and let's say this hollow rim or rail I don't want to have in my model, so I can go and select multiple objects and then just use the filtering options here, and I can see it's disappeared from the scene. But I would spend a lot of time to doing it one by one and selecting. So there's another way how to do it, and that's a little bit smarter, but it's not always 100% applicable. It depends, and it's by the attribute. If I will select this this object here, I can see its attribute. I can go through it and look if there is maybe something that can be some attribute that can be used to get rid of all other objects which are sharing that attribute. So maybe this description, it looks like some cross section, and maybe all the rims around, they are sharing this attribute, this cross section. So I will try, and I will click on this minus button, which should now remove all others from the scene. I can always double check what was removed so far by checking the inverse filter. And I can see related by that attribute there were some these two I selected manually, but these, yeah, they've been removed based on the attribute. And like that, I could go through the model and clean it from any objects I don't want to be carried on. I can also save the filters and use them later. And what is a benefit of it, that the filter is shared within the team. So if your colleague or someone else would like to carry on with your work or look at your model, you can always use saved filters. So I have there already something prepared. So this could be a clean step. And let's say I'm more or less satisfied with it. Of course, there are some small pieces here and there. I'm leaving it there for purpose. I just want to show you another nice feature we have with the cleaning. So I will go to the recognizer settings now. Now in the recognizer settings, we're going to define, and Adam was mentioning it, how you can say which object will be recognized as a 1D or as a 2D or maybe even as a solid. This is basically the frame structure, so there will be no 2Ds, but still, if I would like to, I can always create some new group. Say it will be 2D or the solids, doesn't matter. And then I could assign some object to that group, and then this object will be recognized as 2D. Just to. So this is about the recognition and how the objects will be recognized. Then what we can do in the recognizer settings is to map the cross sections and materials. First of all, we need to look for some attribute where the cross section might be stored, and I've already found out that the attribute description looks like something that resembles the cross section. So I will pick that attribute description in the property selector. There's a preview, so yeah, this really looks like a cross section. And then whole model is kind of, every object is grouped based on that attribute, and I can go through it and also to isolate and to see what objects has which cross section, and I can change it by clicking on this pen icon, and you can see it was done automatically. Again, we are a little bit smarter, so we are looking on the actual value of that attribute, and if it is something that resembles the cross section from the library we are using in SCIA Engineer, we are mapping it automatically. But if that wouldn't be the case, we can always pick and choose from the library here the cross section. Now here goes one kind of nice tip that I would have for the cleaning. You can see it's nicely grouped based on the cross sections. And for example, here there is some cross section, and because I'm using the isolate function, I can see it is only maybe few of these small parts has this cross section. So I can just simply remove them all from the scene. It means cleaning them out because they are highlighted but also selected. So this is the nice pro tip how to enhance your cleaning via the cross-section mapping. And in the very similar way, you can work with the materials. You will find just a suitable attribute from the properties, and then you can assign to the group of the members of the objects which are sharing that attribute the material. So now about those small things that I mentioned before, that I've kept them like that on the purpose. And that's the tip number 2, is don't sweat the small things. And you can take it literally, because we have a possibility to say which object is small and which object isn't small. And then when we run the recognizer, those objects can be excluded from the being carried out to the next phases. Now, because this is the frame structure, there are only 1D members. So let's say I don't want any 1D member which has less than 1.8 meters, just to start with. And also, just want to point out that in any settings, we have some nice animated tooltips. So you can always check there what it stands for, the settings. There's also this one, for example. I will turn it on and I will tell you why in a minute. So now in the settings, I've just set the limit for the small 1D members, and I've enabled the parallel member detection. So the small limit is probably clear what it will do, and the parallel member detection, it's very useful for the steel structures. You can see there are some double L cross-section profiles as a braces, and actually they are modeled in a way that is as a two beams next to each other. By turning on that possibility, it will be recognized as one straight 1D member. So it was very useful for this structure. Now, when I'm done with the recognizer settings, I can carry on. And now the first magic will happen. When I click on the recognize, I can see that 665 objects are being recognized, which means we are looking on the structural objects and we are recognizing them, in this case, all of them as a 1D. And we are assigning them the cross-section we said they will have, the materials they will have, and maybe some other properties that are there from the structural model. It didn't take so much time. And now, after the recognizer, because we've set that small that limit for the small 1D members, I can see there are 159 small 1D members recognized. I can verify by clicking on them. Again, I will use the isolate function, so I can zoom in a bit and I can see a lot of small things left behind after the cleaning step. But because I know it I don't need to sweat the small things because there's this very nice settings. Now those are nicely grouped as 1D members. And when I now carry on, those 1D members are going to be excluded from the recognized model, and the recognizer runs again, but without those small objects. Yeah, they are gone. If I will zoom a little bit, I can see this transparent thing is just the reference to the structural model, and these brownish lines, they are actually the recognized model, the first instance of the structural analysis model. And I can see those small pieces don't have any structural analysis object because they weren't recognized. I've put them away. So this is something that I would like to have. Now, in the next step, is the alignment settings, when you can play with system line positioning and with the freezing elements and etc. Why to do that? Yeah, I will zoom in a little bit to explain. Because this is the recognized model only. It means it put the 1D member or the representation of that beam as a 1D line, and it's positioned in the center line of the beam, and it's not aligned. You can see there are some gaps. And now in this alignment settings, you can play a little bit with the conditions, how the alignment will work. And there goes another tip from me is, on the first instance, probably what is the best, go with the default and see the outcome, and then go back and play with it. The alignment settings can look like this, and again there are a lot of nice animated tooltips which will explain you the rules. Here is the system line positioning, and by that I can say how this group of the beams should be positioned. So I can say if it will be positioned on the top of the steel, on the bottom, whatever I want. I can create my own group here and add some additional members there. It's up to me. I will just keep it with the default now. That was the system line positioning, and now element behavior, which we call also the freezing. Freezing means if I will now select few members, add them to this group, then I can assign that this group will not move in the Y or Z axis, and really those members will stay and will be used as a master planes. But I will keep it as a default, and I will carry on with alignment so you can see the outcome. And it was quite quick. I will zoom in, and I can see now there are clashing two models, actually three. The transparent one is the original structural model, then the brown one is the recognized model. It means those with the gaps, and this first instance of the analysis model, and the third one is this grayish lines. It's the aligned model. I can turn off the recognized model, so you can see really just now the aligned model. You can see it was nicely aligned. So this is the biggest piece of work you will be doing in the AutoConverter, and it is transferring the structural model to the analysis model. For that, there is a nicely guided workflow at the top, a lot of animated tooltips, and at the end, you can upload that model, the aligned model. I can upload back to the BIM Plus. By clicking on this icon, I can say it will be the BIM Plus. I can create the model, give it a name, or I can also create a sub file out of it. The sub file is a kind of a open format, and it's based on the Excel. I will just show you the sub file, how it looks like, and it's used mainly for the reasons that some applications, I mean the structural analysis applications, not all of them have a direct link to the BIM Plus and can download the analysis model which would be stored there. For that purposes, we created the sub file. So if you will have an application which is not supporting the direct link to the BIM Plus, they can always use the sub file if they are in our sub family. Actually, Adam mentioned there are nine structural analysis softwares which are chasing to implement the sub file to full extent. It's nothing less than just a structured Excel sheet. It's completely open, so if you would decide that you would like to change now the quality of material, for example, you still can. So that was this one. Now I will just simply show you how to get such a model to SCIA Engineer. I will open SCIA Engineer, and here we have import tab, and there are two possibilities. One is the SAF model, which is that I will just pick that SAF file that I stored on my hard drive, or I will use the BIM plus exchange. I will use just the BIM plus exchange now. And because I'm already logged in, all the teams I'm member of, but I've been working on this team for now. The project under this team is webinar I was been working on. The model was called steel structure, and I've saved it as an analytical model steel structure. And for now, I will just show you that the revision 1, you can just click on the download. Now you have a possibility to remap the cross sections if you'd like to, but I've done it very thoroughly before, so you don't need to do it again. Yeah, and now the work for the structural engineer would start doing the boundary conditions and applying the loads. And then when he will be done with it, he can upload it back as a revision. So let's say that maybe after some work on it, it could look like something like this. So you can see there are some boundary conditions, there is some load applied, and also the results are present. Then I could upload it back to the BIM Plus. Just export BIM Plus Exchange, and because you remember the link to the structural model, I can see everything is already there, and I can create the new revision, include results, and upload. I will not do it now because I've already done it as a second revision of the analysis model, which is the loads, boundary conditions, and results. And I will just show you that in a BIM Plus, in the AutoConverter. I'm going back here. I will go back to the select model, and I will just refresh the page. Yeah, it's analysis model steel structure. There I can review those revisions. This was the first revision. This was actually the outcome of the alignment. And this revision 2 was done in the SCIA engineer. I've added the boundary conditions, I've added the loads, and I've also included the results. So you can see there are some boundary conditions, there are loads, and you can also view the results. Currently, we're supporting the results for 1D only, and the internal forces and the displacements. Okay, internal forces on 1D member, load case 2, magnitude. Yeah, I can say it's only on a global. So this is really just to review and maybe consult the outcome of the analysis. If you don't have a SCIA engineer with you, you can always jump in to this web viewer and quickly show the results and discuss over them. So this was the big piece of a workflow that was that is called conversion from structural to analysis. And now I will show you the second model. It will not take as much time as this one did, and I just want you to show the revision compare. So I will turn off this model now, and for that I've prepared the concrete structure. You can see it has already some revisions, but I will start with the revision 1. Okay. So some simple concrete structure, no brainer there. This came from the modeler, whoever. And then I've created the analytical model out of that concrete structure. It could look something like this. Then the modeler decided that he will do some changes. Those changes would be here in the revision 2. What he actually did, he added some floors and he deleted some columns, for example. I can either manually switch between them, but it's much smarter to use the revision compare, which is the third from the top, update existing analysis from structural model. So I'm going for that now. So in the first step, you can see it's again a nicely guided workflow at the top. In the first instance, I will select the structural model, and here there is a list of the structural models with just at least 2 revisions, and only the concrete structure has 2 revisions. So I've selected it, and now I'm going to compare. I'm comparing revision number 2 and revision number 1. Now, as an outcome of that compare are modified properties, deleted objects, new objects, and etc. I can review what is under that group by clicking on that eye icon. So if I click on that new object eye, I can see in the green that this whole floor was added. And when I click on the deleted object, in the yellow, I can see the columns which were removed. Let's say I will accept all these changes for now to my analysis model. So I'm going to pick the analysis model. So I have their analysis model concrete structure, and I will be updating its second revision. The second revision of that analysis model was just uploaded from the SCIA engineer after applying some loads. You can see there are some loads there, and I'm just showing it to demonstrate that by updating, we are actually not touching anything that wasn't changed. So you will not need to re-input the boundary conditions or loads or whatever. So I will carry on. Now I'm going through recognizer settings, and actually those recognizer settings will be applied only on the changed objects which I selected in the step before. So I will just quickly carry on. You can see I'm recognizing, okay, there may be some error there. So I will just refresh. Okay, concrete, compare. Okay, revision 2. Okay, again, delete it. New objects, the concrete structure. Okay, it was recognized. And now I would align. Yeah, the outcome of that would look something like this. So it's the analysis model for the concrete structure, and the third revision, which is accepted changes from revision 2 of the structural model. I can see that floor was added, and also the loads stayed untouched. Last thing I would like to mention is here on the left top, we have this menu, and I've mentioned before the YouTube channel with the tutorial videos. You can also review them here. They are nicely organized in a let's say chronological way. You will probably start with the first steps video, and as you will go through the tool, you you go just from the top to the bottom. And also there are some links to, if you would be more interested into the SAF, how does it work? We have there a link for the SAF documentation where you can read about the SAF itself. So that was all from live demo, and I will just now switch back to the Adam, and he will maybe answer some questions if there were in the chat. I really didn't pay the attention to them, but yeah. So thank you, and I'm passing to Adam now.
Thank you, Vitek, for a nice presentation. Yeah, if you could please make me a presenter, I would like to share my screen. Yeah. So yeah, you can see, I hope you can all see the questions in the chat, so I can go briefly through them. So first question was related to in which version of SCIA Engineer is the integration with the BIM Plus and AutoConverter released. So the integration with the BIM Plus and AutoConverter, it's in a 19.1 SCIA Engineer version. Then another question was if it is possible to share the files from the webinar, IFC file and the SCIA file. I think that is perfectly possible. So I will contact that the person via the email, and I can provide the files with you. Next question was if you make some changes, geometric changes in the structure model, if they are transferred back to the BIM model. Yes, but not automatically, because we never changed or changed BIM model or structure model, because we are not the owners. So it have to be done, or it could be done by revision compare, and the changes should be adopted by the owner of that model. So as was shown, you need to pick up the changes you want to adopt, and then just create the task, and then the changes are adopted. That's all from, if I'm not wrong, from questions. So if there is more, just ask now, or otherwise we are going to close this webinar. Yeah, and last remark, quite important. If you like it, please give it a try. You have possibility to get 30 days trial. It's fully working version for 30 days. So yeah, I think it's really worth your attention. It could really save your time in your workflow if you are working in the BIM or trying to start working with the BIM. And that's it. Finally, I will show you some useful links in the end of the presentation, so that you can easily, you can easily navigate from that presentation afterwards. So no more questions. Oh, new question. How the loads were inserted in the model? So very easily, because the loads were applied to structural model in SCIA Engineer, so that's very common. And the visualization in AutoConverter, it's just really visualization. So for the presentation, for instance, or you can share it with your colleagues and so on. So the model with the loads was structural analysis model. And next question is, please, can you send your presentation via email? I hope so. So I will contact you via email. Anything else? No more questions. Okay, if you have more questions, don't hesitate to send us emails. We will try to answer your questions later after this webinar. So yeah, we would like to be sure that you have all information. So I'm going to close the webinar. Thank you very much for your attention, and have a nice day. See you. Bye.